Okay, the recording's back on. So welcome everyone. Thanks for joining this Monday session late in the month. Um, First announcement is that we do have our February session already scheduled, so we got that one up. I'll talk about that at the end of this meeting. Before we get into Matthew and the talk today about gamification, I do want to give a brief update on documentation. I know I keep on bringing it up, but I just want to keep everyone in the loop on progress. So what's happening right now with documentation is I am working on getting documentation to a place where this is the new Open edX docs, and educators is the section in which we'll be contributing. And a lot of what needs to be created already exists in the old Read the Docs, which, for a brief history lesson, this is mostly created and maintained by edX.org, aka 2U. So, and it reflects that, there's a lot of things that are edX.org specific, and some bits of context that the Open edX community might want to add. There are some bits, such as the video pipeline and stuff that the Open edX community more or less doesn't have or need to at least talk about differently. So what we're doing right now is we're moving this over to sorry, I keep switching that. Moving this over to docs.openedx.org in a kind of work in progress migration area. And I can only show that in GitHub right now, unfortunately. But essentially, within Docs, there will be this page that's called Migration Work in Progress. The name might change, and it's going to have all of this content that comes from Read the Docs. Because then, once that happens, what we'll be able to do is come into that work in progress area. And I'm imagining a scenario where people are kind of volunteering for different sections, setting up a course, adding exercises and tools, where they're volunteering, and there's a human readable section like this where people can go in and either suggest an edit, which is hopefully as easy as just kind of clicking, finding the thing you want to change, making a change, and then making that suggestion, and it all gets reviewed in GitHub. Or even just making a comment by opening an issue, kind of to put it out there to the community. Hey, this is what I think about this particular document. So the process is forming like that. The challenge right now is just moving this content over. There's a whole bunch of links, both internal and external, that need to be they need to be there's links that are there's discrepancies in links between this Read the Docs and our new docs.edX.org. So those need to be resolved, and that process is happening a little slowly to start, but I think once we get a hang on it, it'll go quickly, and we'll have that ready for folks. So I just want to keep folks in the loop on that, because I know that's been a priority and a desire for this group. So I'll stop my share and I will introduce Matthew real quick. So Matthew is going to talk to us about his experience developing games. Matthew's kind of semi-technical like myself, so he's not a developer. He's someone that, well, he's been in the community for a long time. First of all, started with Open University, worked at AppSembler for a while. Now he has his own consulting work that he does for Axim and for other clients. And he is, in my opinion, a really excellent game storyteller. He's a really excellent storyteller overall, and that comes out in game design. And so what so what he will talk to us about today is how he brings kind of his background in game design to the educational landscape, and how he gets these games built as a kind of semi-technical resource who's not the developer himself. So thanks, Matthew, for talking to us, and welcome.
Thank you. I'm going to share because, being me, I've done some slides, because who doesn't love slides? Let me just pull up.
obviously work where I work or some such similar place.
That's what academia does to you. Just slides, right? Can people see things? Hopefully the right things. Oh, you've got my bars as well. That's wonderful. Thanks, Chrome.
We have a note that your audio is low. I don't know if you can move your mic closer or anything.
I'm probably just not facing my mic and mumbling to myself. Is that any
Mhm.
better?
I think so. Yeah.
Cool. So hello. I've decided to call this Playing Games of Education, just because it sounds whimsical. So who am I and what am I here for? So I'm Matthew, as John so very kindly introduced. I've been knocking around the open edX community for a while now, just over 10 years now. And I've got a game design degree, which somehow fell in there along the way. Um, I used to be a community moderator on the forums, but had to step away from that for a while. It's just too much work. And I've spoken at open edX conferences before, a long time ago. So if you're like, I know that guy, it's probably from back then when I could make it to conferences. I used to work at the Open University and Appsembler, and now I'm doing product management, e-learning, all sorts of consulting. So what I'm going to be talking about today is a quick guide to designing games that aren't terrible for education and how to actually make them a real thing. We're going to cover some of the core tenets of good game design, talk about a little bit about how educational games are different, especially from standard interactive exercises, and how are they the same. And how do we actually build games that meet our learning objectives, and when should you actually build a game? Because the answer to that is not always. So first, let's go right back to the basics. What actually is a game? A game is an interactive activity, but not every interactivity is a game. I'm going to apologize for the huge amount of words on some of these slides, I think in words, so this is mostly me brain dumping. Games inherently tap into intrinsic motivation. The whole reason you want to play a game is typically to play the game. You are motivated within the game by the game itself. And the definition of the player succeeding is defined by the game. You climb the ladder, you finish the story, you beat the boss, you jump on the flag, whatever. The whole purpose of you being in the game is to accomplish the goal that is set to you by the game within the game. You can't really succeed at a game without playing the game as designed, without cheating. Obviously, that's an entirely separate thing, but generally, the goal is defined within the game itself.
So Matthew, we've lost audio, and I don't know if it's a connection thing or what. You can try killing your video. Yeah, we lost it on this slide. Hearing me.
Yes. So,
All right. So nothing yet, Matthew. You can also try leaving and coming back, see if that helps.
How about this? I've switched my webcam mic. It's awful, but it
No.
seems that my regular microphone has had some kind of problem.
But it's very loud and clear. No, you're good now. Yeah,
Okay.
you were I think nearing the end of this slide here. Go ahead.
Okay, so interactive activities, to put it shortly, they're extrinsically motivated. Something outside of the game, or the activity in this case, wants you to complete it, and that makes you want to complete the activity. And the nature of the activity itself isn't intrinsically linked to the interaction that the learner or player or whatever is taking with the activity. The activity could actually be replaced by anything else that achieves the objective. So if we look at an interactive activity and we say, it's a drag and drop exercise, it teaches them the layout of the human brain. Similarly, we could make a video that explains the layout of the human brain. We could write some words that explains the layout of the human brain. It doesn't have to be an interactive activity. It's just generally better if it is. Whereas a game, it's intrinsically linked. The interaction is the game. And I'm going to talk a lot about intrinsic versus extrinsic motivators, because that's really what makes a game above an interactive activity. So what do I mean specifically by this? So,
Hey, Matthew, do you mind
while,
turning your video back on
yeah, sure.
if it works with the audio? Thank you very much.
Hello. Don't know what's going on with that. So the extrinsic and intrinsic motivators are incredibly important to games. Players of games are typically motivated by progression through the game itself, self-improvement at the skills that the game itself teaches them, overcoming a challenge, and occasionally earning extrinsic rewards. So to give you a practical example of this, on the right here you see Baldur's Gate 3. This is a game that I've played far, far too much of recently. You might be able to see almost 500 hours into the damn thing. I played for the first 300 hours because I was enjoying the game. My entire reason for playing the game was exploring it, trying new things, keeping on going through the game and finishing it in different ways. And then I realized there are achievements. Achievements are extrinsic motivators. They do not exist within the game, but they serve as challenges of ways to beat the game. And they are ways to compare against the global community. For example, the last one I completed was completing the game in honor mode, where you only get a single save, it deletes if you die, yada, yada, yada. And I was motivated by the fact that it says 0.5% of players have achieved this achievement. This is an extrinsic motivator. Like, I didn't need these to play the game. They didn't at all drive me to play the game. My wife, though, is very heavily motivated by these sorts of things, which is why she played with me for those 500 hours. But primarily, if the intrinsic motivator wasn't there, I wouldn't have played the game this long. You can play a game that only has intrinsic motivators. You cannot play a game that only has extrinsic motivators. You will just get bored and stop playing. And that's the general goal of any game, to keep people engaged within the game and playing. It's not, when you design a game, you're not saying, I want as many people to finish this as possible. I want as many people to reach the ending and learn the secret. The goal is the journey along the way. Something else that makes games games is that they're one of the only art forms that says no to the person trying to enjoy them. I will admit this is stolen entirely from one of my favorite comedians, but it's so true. Netflix doesn't stop partway through an episode to ask you to complete a series of multiple choice questions about the themes of the series so far before it will let you watch the next episode. Art galleries don't have an obstacle course in the foyer. You don't have to solve a puzzle to go to the movies. While the goal is always to have the player experience the game, it's fine if they fail at it, over and over again if necessary. You'll see the GIF here is from Dark Souls, which is a notoriously unforgiving game which just likes to punish you for no reason. There's a lot of people who very much enjoy that and see it as motivating. There's a lot of people who absolutely hate it and will not play it. But it's fine if you fail at Dark Souls, because the solution is getting good. Games teach through failure. That's how they teach you to play the game. They might have a basic tutorial at the beginning, which teaches the player which buttons to press, how they interact with the game, how they have the ability to interact in the game world to manage to fail. Like, you have to get them to the point where they can convincingly fail. But after that tutorial, they will almost always have something that has the likelihood or potential for failure. It might be a hole that kills you when you jump down it, or an enemy that kicks you off a ledge like we saw on the previous slide. But you cannot have a good game, educational or otherwise, without embracing the fact that to challenge learners, they have to fail, be motivated to dust themselves off and come back and play again, which is something that's very different from your standard educational exercise. When you design an activity, the idea isn't like, we're going to make them fail here until they get it right. It's, you want them to complete it and see what they've learned most of the time. It's very uncommon that you'll create an interactive activity that's designed to say you lose to a learner. And with games, if there's not enough of a challenge, the game is not fun and players will stop playing. But similarly, if there's too much of a challenge, the players will give up and stop playing. So you have to strike that balance between kind of challenge and success.
And one of the ways that games, oh, excuse me, one of the ways that games do this is by a concept called gameplay loops. So this is kind of a game design fundamental that I could talk for hours about this, but I'm going to try and condense it down as much as possible. So forgive any kind of jumps in my logic here. So a gameplay loop is a fundamental way that you can break down a game and continually motivate players. So this is a very basic loop. A player may start with a challenge. They'll attempt to overcome it and loop through until they actually overcome it. And then they'll get rewarded, whether that's level ups, power ups, items, just new content to try. And that's a very basic loop because it keeps the player motivated. It keeps players within the loop. It feeds into itself. The challenge gets harder. They get more stuff at the end, which helps them overcome more challenges. It keeps the loop building and building upon itself. If we look at a standard, if we apply this concept, to a traditional learning activity, there's nothing wrong with a learning activity. Not every activity should be a game, but this loop is flat. It doesn't escalate. It doesn't motivate learners to continue going because you don't want that. You want them moving on to the next piece of content. You want them to learn what they're there to learn and move on. It relies entirely on extrinsic motivation from the course itself to motivate learners to complete it. Learners should complete the activity because they've been told to, because it's part of the course, because it will teach them a thing that they need to learn for the exam, whatever. There's no intrinsic motivation within the loop because the learner is just presented with content, asked some questions, answered, presented with content, and so on we go. There is a loop, but it's not a loop that motivates the learner to complete it. Now let's look at gamification. Spoiler alert, I actually hate the term gamification. If a lot of the time it fundamentally disregards a lot of the principles about what actually makes games work. In this loop, you see the learner's presented with content, the learner's asked a question, the learner answers, and the learner receives points or a badge. And then we return to the standard learning loop. Like there is kind of a loop there, but it's exactly the same as our traditional learning activity. There's no escalation, there's no motivation within the loop to keep people engaged. All the motivation provided is still extrinsic. We've added extra extrinsic motivation, and some people do find that incredibly motivating, don't get me wrong. Like, that is a thing that has value. People can and will just go and collect badges. They'll compete on leaderboards to see like who's answered the most questions or whatever. But it doesn't motivate them to complete the questions for the sake of the questions, which is something that games do. So let's instead look at a basic learning game. Now, this is going to be a good game. It's not going to be the best example, but this is a very simple gameplay loop. So we have a challenge. They try until they complete it, and they receive some of their points and badges. The way we turn that into intrinsic motivation is we actually use those points and badges to unlock harder challenges. That turns it from a gamified activity into a game, because the game itself rewards the player within the game for completing the thing that the game wants them to do, sorry. And that's a bit of a weird concept, and it sounds like I'm saying the same thing and saying it's good, but if you take nothing else away from this, a true gameplay loop requires feedback into the game itself. It doesn't repeat the same thing that you've already done. It doesn't pose a different question in the exact same way. It doesn't like move you on to the next multiple choice question. A gameplay loop has progression within the game itself, or makes you want to complete it. And spoilers, that's going to come up later, so I won't harp on more about that again. So let's move on for a sec to when you should actually build a game, because that's not always. You should build a game when you can clearly envision a gameplay loop, or when repetition will be beneficial to the learning outcome. Because to make a game, you have to be okay to make learners fail, and failure inherently ties to repetition. And it should also be when repetition is beneficial to the learning outcome. And you also need to be able to have fun with the subject matter. Nobody wants to play or greenlight making a game about bloody historical massacres in an education setting. There's probably a market for that in the games industry somewhere, but nobody wants a game about that. And also, your audience has to be likely to enjoy games. We're talking younger learners, for one thing. If you think that your course is going to be heavily studied by 70-year-olds, maybe not make a game for that course. Games have to be interesting to someone to start them in the first place before they can enter that loop and be motivated by the loop. If you can't say all of these things are true, then maybe you shouldn't make a game, is all I'm saying. But let's say you do have a good game idea. Your subject is great. There's a clear loop that you can think of and write down on a piece of paper and explain to someone in easy words. Or repetition is valuable, or ideally both. That is the perfect game to make. Anything where repetition and a loop make sense, you've got a game. But let's get it built. So you've got this design. How do you actually get it built? How do you get it greenlit? So firstly, make sure you haven't designed around physical interactions. This is a challenge because most popular video games and board games or whatever involve some kind of physical interaction. The problem is, a game like a platformer, like Mario, for example, is fun. But if you build an educational platformer, the challenge becomes the platformer, not the education. Learners with disabilities become less and less able to participate. And generally, you may miss the point altogether. And if you can't point to clear success from the game, then it's going to be impossible to get another game made if this one even gets made in the first place. The next thing is design for reuse. This one is absolutely vital, particularly in an academic setting. If a game concept works for one subject or theme, it will likely work for a lot of other games. So see if you can separate your game from the subject where possible. This makes its development easy to justify because once you've done one game in that engine, you switch up all the graphics, you switch up all the data or whatever, and suddenly you've got another game that can be used for 50 other courses. That makes it so easy to justify to the people who are controlling developer budget. Because suddenly they don't have to make these games every time you want a game. And believe me, if you make a game, every other faculty is going to want a game. Every other department is going to want a game. Every other course team is going to want a game. Because if they see your game, they're going to want it. So if you get your game built in such a way that it requires very minimal effort, very minimal technical skill to reuse it, you can get that game made and you can get a lot of other games made. This ties in a lot to the next point of adapting existing game designs. This is boring. Everyone wants to make their own game, but the people who have made games that exist already have already done a lot of heavy lifting and research that you don't have to replicate or communicate. You need to overcome your ego when designing new games because there are no new ideas. It is fine to make a game that is like blank, but change. You know, like Mario, but he flies. Like Dark Souls, but you're a goose. I don't know. Same goes for educational games. If there is a game that you've seen that works, think about how you can repurpose it into something that is an educational challenge. But when you're doing so, you need to be extremely practical. The lower the lift, the less help you need to make the game a reality. There's an old joke among game designers that graduate game designers will always come out of university and say, my dream game, I'm going to build an MMO. You're going to fly through the skies. There's going to be 5,000 people around you at all times. Everyone's going to interact. You can do anything. A good design is a constrained design that is practical, that can be executed upon, and works. And the way that you know that your concept works and is fun is paper prototyping. I cannot recommend this enough. If it's at all possible, write it on some paper. Build a paper prototype. Tear up some paper, make some cards or whatever, or game pieces, play it on a piece of paper before you ever get to the point of asking a developer to build anything. Because about 75% of the games you come up with education. If you're following these other rules around interactions being limited and designing for reuse and being practical, you can probably find a way to make it work in person. So I'm going to show you a quick example of that and a game that I worked on with the Open University, which started out as a paper prototype. This is Moon Trumps. You can access it at the URL still because they ported it out the course that it was in and did God knows what else to it. But essentially, this follows a lot of those rules. This was a game that was made because the faculty needed a way to assist learners with memorizing not just facts about moons, but compare moons. And the way we did this was we based it on an existing card game, Top Trumps. Those of you in the UK, if there are any, may recognize Top Trumps. I know it's in America, but it's a lot smaller than it is here. Top Trumps is a game where basically you just pick things on a card to compare to another card. I'll show you how it works in a sec because it's still online. I can play it for you. But we built it for reuse. All of these moons, as you compare in the game, are reading XML files with all the card data. So anyone can just add cards as they wish. They just tell it where the image for the moon is, you tell it what the color of the card should be and what its different attributes are. And it's part of the game now. You could infinitely expand this without ever needing a developer because all you do is edit an XML file. Anyone can do that. And we worked on this first with paper prototypes that we played in meetings. We played at our desks with little pieces of paper. We saw kind of which attributes were most hard, or most fun, or otherwise, and figured out how to make the game work. So I'll just quickly show you over here. Hopefully this is still showing. If it's not, please let me know. Cool. So this is very basic. I will not say it's the finest game ever made, but it's a very good example of how simplicity and reuse works. We put this into a very early MOOC that I worked on called Moons, unsurprisingly, all about the moons of the solar system. So this game is very simple. You have some cards. The computer has the same amount of cards. You pick which attribute you want them to compare against, and the person who has the highest takes the cards until someone runs out of cards. I'm probably going to lose this because it's been very many years since I played it, but you simply see, so this is Oberon. You've got these categories, radius, density, orbital period, orbital radius, and potential for life. Some of the categories you pick the highest, some of them you pick the lowest. That was a design mistake that we made. It should have just been the highest, but these are the things that we wanted people to know about. And the general thing, I'll just talk as I play, is that, yeah, you don't necessarily want learners to remember all these stats about moons. But for example, this is a good one. I remember that Sycorax's orbital radius is insane. It's a really long way out from the sun, from its sun or its body. I can't remember actually. That's probably another mistake. But you tend to remember the things that are the most. This is how I remember things like, I believe the moon is the densest moon in the solar system. You can start to pick up these things because when you get these cards, you remember that I should pick this one. The other mistake that we made with this game is that because in typical Top Trumps, whoever won the last hand goes first, it is entirely possible to just sit and watch the computer beat you. But this accomplishes a lot of the learning goals that we came up with and really entertained a lot of learners at the time because people just wouldn't stop playing it. There are multiple difficulty modes that we put on this to make it easier for certain people. We had a dumb version of the AI and the smart AI. People were obsessed with beating the smart AI. Like they were sure that it was cheating, they were sure that it was impossible, but they would not stop playing it. And that ties into another thing that you should do with your games. If you build games, where possible, if they're playing them online, keep track of how people are playing them. Keep track of who is succeeding, even if you're just logging every time you've got a successful game versus an unsuccessful one or whatever. Track and log. because that will let you track the effectiveness of your game. If you can see that over time people tend to get moon trumps more and more correct, that means they are learning something. So that's, I believe, what we did on this one, or at least we talked about it at great length. Like I say, it was a very long time ago that we built this. My memory isn't absolutely perfect. So let's get back onto this. Woo. Only a couple more slides, I swear, and then I'll answer questions for my ramblings, if there are any. I can't move the speaker view out the way of my own slides, which is great. Thanks, Graham. Okay. So I was going to end with that, but I had one last brainwave at the end when I was running through this with my wife that I wanted to make sure we cover. I couldn't find somewhere to put it, so I'm going to talk about it now. Avoid rabbit holes. Your games need to be fun or they have no value, but you have to achieve your learning objectives. It's not enough for an educational game to just be fun, just as it's not enough for an educational game to be educational. It has to also be fun. And balancing the two is difficult. If you lean too hard on extrinsic motivators like course completion, your learners won't care about the game itself, and you might as well have just made a video. You've wasted developer time by making that game. However, if you lean too hard on intrinsic motivators, making the game fun, making the game engaging, keeping people within that loop, the game might not teach them anything, and it's going to hurt them completing your course. People only have limited time for learning, and games are intrinsically a time sink. They're a rabbit hole. So try to keep your learning objectives relatively simple to accomplish when you build your games. Keep gameplay fun and intuitive to decrease the on-ramp and how much people need to engage with them in order to succeed. And keep it elegant. The fewer moving parts, the better. Moon Trumps worked as a game. I don't think it's the best game it could have been, but it definitely worked. And all it was just a couple of cards comparing. The more complex your game is, the harder it's going to be to make, the harder it's going to be to get people on board with it, and just, it's not going to be as good a game. Good game design is elegance. And that's all I've got for you now. So I'm going to stop there. And if there's anything anyone wants to ask, I don't know if I've still got time for that or not, but there you go.
You definitely do. I have plenty of questions, but I'll open up the floor. People can just raise their hand and ask Matthew a question. And I have lots, Matthew, so I can start.
Okay. I'm never sure if that's a good sign or a bad sign when people don't have questions, because it means either nobody cares what you just said or you've just explained everything.
It's a good sign. I always enjoy hearing what you have to say. What I wanted to ask first on the list here is, can you talk at all about the process of working with the developers, what you did, what they did, how that, anything about how you found them, how you work with them, that kind of thing.
Yeah, so with Moon Trumps in particular, I'm going to stick with Moon Trumps as an example because it's the easiest one that's top of mind right now. What we did early on was we sat down and we came up with basically an interactive library that we'd be building. So we came up with some basic games that could be implemented kind of subject agnostically. And then we basically implemented it. So and that sounds like a lot of we did the game, but the main thing was that the game was built in such a way, well, the game engine was built in such a way that anyone could build games using those tools. It wasn't pretty, there was no like fancy UI or anything, but it was all done through simple XML editing. So I was actually the one who put together all the cards and everything for that Moon Trumps game. I did tweak some of the code behind it when it wasn't the way I wanted it to be. But mostly we had a developer build the skeleton and then adapted it into the game we wanted it to be through less technical means, which is definitely a way to work.
Were there plans to build this into different games? Did that ever happen for open learning?
I honestly don't know. I know that a bunch of faculties immediately latched onto it and tried to include it in their courses. I just don't know if they got approval to do that. I hope that they did, but I don't have access to I didn't have access to all of their paid degree programs where they wanted to adapt it to. So I couldn't say for sure.
I can, oh, sorry.
No, you go first.
Thanks, Julie. Matthew, I would just love to hear a little bit about, a little bit more about your experiences in sort of like connecting learning outcomes or objectives, or even, I mean, I don't even know, maybe potentially assessments, to the stories within the games, or what you would recommend or best practices in working with, faculty or subject matter experts in kind of how to, not necessarily convince them that a game is a good way to go, but how do you make sure and how are you checking that those learning objectives are being met?
Yeah, so that's a tough one. It's probably the toughest thing with games. I'd say that stories are hard. Stories are inherently intrinsic motivators. And you can tell a story within a course, within a game, sorry, and that will drive a learner to complete the game because they want to get to the end of the story. They want to know how it goes next. However, that becomes a lot more difficult in education, simply because that introduces more external factors to the game itself. It's fine in a game if the player doesn't like the main character very much. They may stop playing because of it, but you don't really mind that much. Whereas in an educational game, obviously you really want your learners to actually play the game. It's part of the course's kind of budget and outcomes. So when it comes to a story, simple is definitely better. And if you do have a story in there, because you don't have to have a story in there, learners do have plenty of extrinsic motivation, and you can build intrinsic motivation through good gameplay design. You don't necessarily need to throw a story in there to muddle things up unless it's absolutely necessary. So, for example, one game that sadly didn't get made in the end, that worked on with the Faculty of Health and Social Care, was a game where essentially you were taking the role, which is an important thing I'll talk about in a sec, actually, taking the role of a social worker, managing different cases, and how you manage them impacted consequences and score and all this stuff. It eventually ended up not being made, though, because a lot of that subject matter was very hard-hitting. That kind of speaks to the setting the correct mood that I talked about in the presentation of like, well, maybe actually a game isn't the right way to talk about that kind of subject. We ended up with an interactive exercise where it kind of walked you through case studies, but we didn't make the game version of it simply because we discussed it and it actually wasn't the right thing to be doing. I've rambled a little bit, so I've forgotten what else you asked. Was there something I haven't covered there?
No, I think that sort of the best takeaway from your answer there is that, yeah, you don't necessarily need a story, right? Like if you're gamifying something and it's specifically for, tied to the learning outcomes or specifically for assessment, that like a background story might just muddy the waters and make it kind of maybe either unrelated or just overly complicated and maybe not even worth the like development time and cost. So that's really great. No, I appreciate that. Thank you so much.
Yeah, and yeah, I think you're exactly right there in terms of like, you've just got to look at everything you add to your game as a zero-sum equation, right? Anything that you add to your game is something else that you can't be focusing on, is something else that is potentially in the way of the learning objective unless it communicates what you're trying to teach. So you have to think really hard about each and every single piece of your game as a piece of the game, whether that's the story, whether that's how they interact, whether that's the artwork style even. All of those things can become barriers if they're not properly handled. So don't add a story for the sake of the story ever. There's definitely a good rule to go by. I do see one from Joanne. Software that can build games that don't need coders? Yes, absolutely. Not all of them are great for building games that are played on the web, though, is one challenge. But one that I will always recommend, will always recommend is Game Maker Studio. They've recently made it free. It can output HTML5. It's not particularly good HTML5, it's not particularly good code, but you can use it for prototyping, which is another good way to get something made before engaging proper coders. Because if you can build a prototype of your game and you can show that it's fun and works, then yeah, that's incredibly powerful. Oh, John has a hand.
I do,
Well,
yeah,
Zoom
because
can
I
do
also
that.
I also have one that's very near and dear to my heart, that Joanne, I mean, anytime anyone asks me about it, and I have wanted to do a session on this one for a little while. I don't really want to monopolize, but Twinery. So it's twinery.org, and it can make outputs like this, like these kind of gamified choose your own adventure type things. This is a cybersecurity one. I don't know if anyone from NDI is on here, but this is a cybersecurity one, where you choose like what tools to use in certain scenarios. You get feedback. Like I chose the wrong one here, so my characters are unhappy about it. And that's built into this tool called Twinery, which is a browser-based tool. Doesn't require code. You build it like this, basically, where you have these like passages. So you add a passage and you say, it looks a little bit codey. I can find, you know, here's a very simple one. You have these passages and they go to different paths. So there's a button for win, partial, and lose. And if you're to play this, you can see that. And so what this is really good for is like case study type games, choose your own adventure type games, story-based games. We just talked about stories. And to take it one step further, because I like this thing so much, I do have a template that I built for it that you should, not that one, this one, you should be able to download this. And if you build with this template, which is free, you can get the grading to work in edX. It gets mildly technical. If you want help, I'm very happy to guide you a little bit. But you can basically get it to send your score to edX. That's what this is doing, depending on where you end the game. So a little plug for Twinery.
Yeah, it's very good for kind of those narrative experiences. Yeah, definitely agree with that. The initial process we played with physical pieces, yeah, that's actually a really fun thing to do. We basically had ourselves a little hack day, where we talked about what we wanted learners to learn from the activity. Like we wanted them to primarily be able to identify the most of things or the least of things. And so this was kind of before the bundle of different interactive tools was designed, because, you know, it was not fully formed yet, the idea of, you know, we could have a Top Trumps game. Top Trumps is very popular over here in the UK, by the way. It's not something that we came up with at all. The game itself is just an adaptation of what's probably a licensed product. We're not sure if we ever cleared that, but it's, once we had that concept of what are we teaching, we brainstormed different ways of, like, you know, how do we come up with that sort of thing? How do we compare moons? Comparing was the key thing. And so we literally came up with things that moons have. We wrote them down on pieces of paper. We filled in some stats on them from Wikipedia or something. And then we literally just played Moon Trumps. We came up with our own cards just on pieces of paper, and we played the game. I've lost it, or I'd show it to you, but later on we printed up the game on actual playing cards. So I've got a physical pack of Moon Trumps somewhere, which is very cool. But sadly I don't have it anymore. But the game works in paper form, in card form. And a lot of really good learning games will do that if they're not entirely tied to a story interaction or something like that. So we just played with it, basically. Play is very important.
So do you have any insight into games that, so I have friends that are game developers, but specifically board or like hands physical things, not computer games. And so do you have any insight on when something, where that that transfer would be, when something that you can do as a learning activity that incorporates hands-on things would make a good game? Sorry for the cough.
So I would say that if something is fun as a hands-on activity, it will be fun as a video game. The only problem is you'll probably have to come up with a computer to play against. That is by far the hardest part of building anything like that. Teaching a computer to play your game is a challenge because one of two things will happen. You will be able to train it to make completely random decisions, which will make it no challenge whatsoever to play against, which is the dumb computer, by the way, on that one. Or you will teach the computer to play your game so well that it will be solved, which is the smart computer. Smart computer on Moon Trumps, if it has control, will always make the best choice. It will play the game as optimally as it is possible for it to play. And the only time you will get control back is if it happens to have a bad card. It will not make a mistake. It will not do any of that stuff. So that's where it tends to be a challenge, translating physical games, because physical games, board games, I love board games, I'm addicted to them. They have the advantage of having another player there, another person. And to adapt that into a computer game, you have to either deal with player-to-player networking, which is a nightmare, don't do it, or an AI-controlled player, which is a problem. Obviously, you can have games that don't require an opponent, that you can just play by yourself. And the same goes for physical games as well. You know, like Solitaire is a perfectly reasonable game to play by yourself. So that's not always the case. And if you can come up with a game that is fun to play single player, that's huge. And that can be quite easy to prototype as well, because, you know, even if you're doing solo interactions, even if it's just a case of, you know, if you're writing a story game, I think very physically and visually. So like get some index cards. I'd write index cards, I'd put them down and I'd connect them with string or something. That would be paper prototyping for me. And then it's just a case of capturing all that work that you've done, all that design that you've made into a form where it can be turned into an interactive digital experience. I think Game Maker Studio is only available on Steam. Sorry, I just saw Tom's question. I think it is only available on Steam now. I know there are older versions that aren't, so it's been a while since I've checked in on how they're distributing on other platforms. Yeah, sorry, Julie, I hope that answered your question.
Oh, no, that was great. That was because that gave some insight into some of the first steps. Yeah, I mean, you had talked about them during the slide part, but that gives that gives me a better sense of those first steps.
Yeah.
So we have a number of activities that we've been using for high performance computing that we're trying to. We need to scale out the training of high performance computing. So
yeah.
it'd be fun.
And yeah, absolutely the first step is try and take your game as far as it can possibly go before writing any code whatsoever.
Mm-hmm. Yeah.
Because that will reveal a whole bunch of mistakes that you've made or assumptions that don't work or things that just aren't fun. Mm-hmm. If you can play your game, you can tell it's fun.
Thank you.
No worries. Developer process times and costs. Obviously, that's sorry, Joanne. Joanne's asked, can you talk about developer process times and costs? It's very much a how long is a piece of string question. The more simple and more elegant your game is, the less time it's going to take. Probably, if you didn't care too much about the speed of it and the quality of it, a developer could probably bang out that Moon Trumps game in a day. It's not an incredibly complex game, or they could at least get it to a digitally playable state. And then from there, it would be optimization. However, if your game is massive and uses loads of things that aren't available out of the box, then it's going to take a lot longer. And a lot of your time spent as well will be on blockers. So, for example, if you don't develop your educational game as far as it can go, if you don't come up with the academic content or whatever that's in your game, what will happen is if you hand it off to developers and you go, okay, I'm going to go work on something else now while you build that, and they hit a snag, they find something's not right, they find something's not great, or it doesn't work or can't work the way you envisaged it, that will block them. And the way developers work is if they are blocked, they will do something else. And if you leave them blocked, the thing will die. So it's almost always better to try and get these things out in as short and intensive a period as possible. Kind of just earmark some time for yourself and for the developers, get it built, interact between you, be highly collaborative, and just get it done as quickly as possible, because it's not about having it available as quickly as possible. It's about neither you nor them getting distracted and getting blocked. So that would be the number one thing I'd say about that. Costs and time is obviously going to be incredibly region development and dependent and kind of scale dependent. So that's the best answer I can give for that, I'm afraid. I'm just waffling at this point. Hopefully that's helpful. Was there anything else? And yes, looking at that link, that looks like the game maker I'm talking about, Tom. I highly recommend it. I love that thing.
I'm excited to check that out. I have not played with Game Maker.
Now's a very good time because they've literally just moved to a free model. Before this point, you had to pay for it. Now I believe all you have to do is pay for the licenses for things like Android. So
very cool. Very cool. Well, thank you for talking with us, Matthew, and answering all those questions. It's always great to hear what you have to say. So this was really, really educational and really entertaining. I love talking about kind of the gamification space and taught a lot there. So thanks everyone else for joining. Oh yeah, next one before everyone leaves. February 12th, which is 2 Mondays from now, we have our next session. I know that, Matthew, slides, can we get those available somehow?
yeah, absolutely.
I'll post them. If you give them to me, I'll post them on the Educators Working Group.
Sounds good.
So 2 weeks from now on Monday, we will have Rebecca Rumble from Penn State Extension. Some of you may have recognized her. She's also was part of the edX conference recently. They do some really great work on video production, I think. They have a really streamlined, really efficient video process. I know that a lot of us deal, at least tangentially, with videos, and a lot of us deal with the constraints of, we are not Hollywood. We cannot produce videos on a Hollywood budget. And I think that Penn State Extension is one of the best at putting together really good video, a large library of video on, I think, a really efficient, I don't know what their budget is, but like on an efficient, seemingly budget for who they are. So that's coming up in 2 weeks, and I will send the invite out soon after this, maybe tomorrow or so. I'll send the invite out for that. So we do have the one scheduled now. And with that, I will I'll close it and say thanks everyone for joining. Thanks again, Matthew.
No, thanks everyone.
Thank you.
Thank you.
Thank you.
Have a good one.
Thanks, Matt.
Thank you.